I'm Michael Nelson, and welcome to the session on what does artificial intelligence, machine learning, and big data mean for the internet. This is a 75-minute session, but we're going to try to cover approximately 3 hours of material. We have some amazingly talented people, and they're all going to talk in tweets. I would like to say I have put out a Twitter poll for all of those who are watching in live stream. We have put out 2 questions. Question 1, what application of machine learning and the internet most excites you? And this can be something that already exists, or it can be something that is going to happen in the future that maybe a year or 2 or 5 years away. The second question, also on Twitter, is what most scares or concerns you about machine learning and the internet? And so just go on hashtag IGF-USA or Twitter handle IGF-USA, and you'll see this question. I posted it this morning under Mike Nelson. Anyway, let me get going here. I'm not going to talk much because this is all about our panelists and about you, the audience. We are going to leave a lot of time for Q&A. Let me first turn to Bill Shirless. I'm not going to give a long bio. It would take about 5 minutes for him and 5 minutes for each of the other members to cover their accomplishments. His bio is on the website. Bill is a professor at Carnegie Mellon University, but fortunately for us, he's agreed to come to Washington and work at DARPA, where he's heading up much of their information technology research, including a lot of work on cybersecurity, artificial intelligence, machine learning, and everything else. So I'm going to turn it to Bill. He's got 2 tasks, and he gets a few more minutes to both provide a view of the horizon, what's going on with artificial intelligence, and then what is DARPA doing, what's DARPA most excited about when it comes to this technology. So over to you, Bill, and I hope to see lots of questions posted in Zoom and lots of replies to the survey question on Twitter.
Great. Thank you very much, Michael. Just making sure, can you hear me? Just give me a signal. Excellent. So I appreciate the opportunity to speak and engage with you all through this wonderful online conference. At DARPA, we've been involved with AI for more than half a century. 60 years, in fact, almost all the way back to the Dartmouth Conference of 1956 when the term AI was coined. And of course, we've been involved with the internet for about the same period of time, not back to the 50s, but certainly for more than half a century. The internet has enabled us to do AI research over the years, all kinds of AI research. The question today, though, is what is AI enabling for the future internet? So first, what is AI? There is no hard definition, but I thought I would offer a common framing, which is that AI is the application of computer science and other disciplines, cognitive science and the like, to automate functions that are commonly believed to require human cognitive capability. And the commonly believed part of this definition is very important because the scope of AI has evolved really dramatically over the past 60 years. And we have these remarkable capabilities, which is, in fact, why we're here to talk about it today. It's a lot more than modern machine learning. There's, for example, the early symbolic AI tradition, which really surged in the 70s and 80s. TurboTax is a great example where we have explicit rules that are wired into systems. A lot of robot control is in this category as well. Knowledge representation, search, planning, and the like are all in this category. And then we have the modern statistical tradition inspired by neural models, what's most familiar in the kind of the zeitgeist of the moment. But in fact, this has a long history going back to the 1940s with McCullough and Pitts, and statistical machine learning going way back, certainly to the early 80s. But there was a threshold crossed about 15 years ago of scale and scope that has brought it to our attention and with significant impact in many sectors. But there's some non-obvious applications. One, for example, is Siri, which actually is a DARPA outcome. Machine learning is also helping us to scour the medical literature. We're doing that right now to identify candidate therapeutics for COVID among, for example, drugs that have already been through safety trials. So those are the traditions. So some examples of what's going on in DARPA programs right now. We have programs that are making use of machine learning and AI to detect deep fakes. And of course, AI is used to perpetrate those deep fakes, generative adversarial networks, GANs. So there's lots of AI on both sides of that engagement. We're looking at deepfake imagery, videos. Now we're moving to text and voice and narratives. We're also looking at how AI capabilities can partner with humans in a way that is effective and also, how do I say this, not annoying. This means that we have to model, the AI systems have to model the state of interaction, how to add value to the human endeavor, when to interrupt, when to ask for guidance, how to represent those models. We also have programs that are focused on making AI safer to adopt. Adversarial AI, the spoofing that we're familiar with, where we can put stickers on a stop sign and turn it into a speed limit sign in the judgment of the network classifier. The question is, how can we understand and expand the envelope of safe use cases where these machine learning networks are both, they're fragile and they're opaque and they're easily spoofed. So there are a number of programs focused on that. For example, extracting mathematical models from machine learning networks, smaller ones that allow us to reason about them, building machine learning networks that more readily support explanation and the like. So I've just in this 1 minute, I've referred to about 8 different major DARPA programs. And these are all programs that are currently in operation. So just to wrap up, the question is now, where are we going with AI in the future? You know, in the world of tech users, there's often a sense that we have arrived. We are now at this new world of modern machine learning. We have this great technology. We can do awesome things with it. And so here we are. A sense almost that we're kind of at a plateau, a new plateau. Well, this is a perception that comes every few years in computing. You know, we've got cloud, we've got AI, we've got data, and so here we are. And what do we do with all this? The most important message that I'd like to share with you today is that there is no plateau. We can talk a lot about today's challenges, adversarial AI, machine learning and data in the cloud, and so on. But it's really important for us to be understanding what the future might bring and to talk about how we can, as a community, proactively be pushing ahead. And so I'm just going to mention a few directions before I hand this back to Mike. One is, can we create a new generation of AI capabilities that harmonize symbolic AI, where the reasoning is explicit, the domain concepts are there to be seen, we understand the rationale for conclusions because it's fully exposed, with statistical AI, which is more scalable, but much more opaque and more easily spoofed. So if we can marry domain concepts with statistical approaches, maybe we can get the best of both. A second area is to push the idea of what we call metacognition, which is learning how to learn, thinking about how to think. That's what we do all the time to drive that AI evolution. And some AI people argue that you can't do the harmonization without the metacognition. Metacognition is an idea that was introduced by Alan Newell back in the 1980s in the world of AI, but of course it's been in the world of cognitive science going back to the dawn of the ages. And then a final area is just to push on the various dimensions of cognitive capability, natural language processing. DARPA has been an area of focus for half a century. We continue to push on this because there's still much more to be done. The engineering of AI systems, the use of AI to support scientific reasoning, and one area that's of interest to me for people who are contributing to the scientific literature, we have a program that I referred to earlier, which was doing kind of forensics in the literature to identify mechanisms for drug activity when those mechanisms are spelled out across maybe several dozen individual technical papers to build those kind of semantical links in the literature and draw conclusions from that. Well, maybe we can think about doing that proactively rather than just citing papers. We can build those links proactively in the literature and have a balance to that forensics. So some questions for everyone here. What else should we be pushing? And what are the great ideas in AI that you would like to see? Mike, back to you. You're on mute, Mike.
I promised I wasn't going to do that. But I challenge you to put those questions in the Zoom chat, and our participants can start answering your questions as well as my questions. And if you do have any links to reports on what DARPA is doing, put that in the chat as well. We're going to try to cover a lot, so I hope the other panelists will do the same, either now or after their talk. Our next speaker is Jen Golbeck. She is a professor of information studies at the University of Maryland. She's a former head of the Human Computer Interaction Lab. And she, for my money, she is the best tech explainer in the Washington, D.C. area. So over to you, Jen. And again, try to keep it to about 3 or 4 minutes so we can cover a lot of territory here.
Thanks, Mike. Yes, I'm a computer scientist, and normally when I go around talking about AI, which is something that I build in my own research, I'm trying to scare the crap out of everybody because there's all kinds of like really terrifying stuff that's being done that's privacy invading and socially bad and also just scary and not thought well through. I think other panelists will probably cover that. If you do want the crap scared out of you, ask some questions because I'm really good at that. But what I wanted to take a couple minutes to talk about today is how we're thinking about shifting that a little bit in my research. And I think other people, are starting to pick up on this. So one way that you commonly interact with AI in your everyday life online is in social media when they kind of choose an order to show you your news feed, or like on Amazon and Netflix when they recommend things to you. And sort of as a whole, these are all called recommender systems, things that personalize what you're going to see in the context of a whole bunch of other data. And traditionally, those algorithms are optimizing for engagement. So it looks at what do you click on, what do you like, what do you view, what do you comment on? These really easy things that we can measure about how you interact with it. And then we make these algorithms show you stuff that you're likely to interact with more. So movies that you're going to like, posts that you're going to like on Facebook, things that you're likely to retweet on Twitter. And that's been good. But the problem is that we've seen over the last 3 or 4 years that can also go astray. So we've seen on a lot of these platforms that optimizing for engagement is directing people towards more extreme content. Facebook, for example, there was just a Washington Post article that I think a Wall Street Journal article that showed that something like 70% of people who join alt-right groups on Facebook do so because Facebook suggests them. And that's just because we engage more with content that makes us upset. And so if the algorithms are optimizing for that, they are sort of unintentionally leading us to bad things. And I started thinking about, are there ways that we could make this work in the other direction? I put my dogs on social media. This is Art of one of them back here. They make a lot of people happy. And I've heard people saying, I want to just sometimes come online and feel better. And so I looked at, well, could we use this technology that we already have? Instead of optimizing for engagement, we're going to optimize for well-being. We're going to show you the stuff that's going to make you happy. And essentially, that doesn't involve any change to the AI, which is very good. It changes the data that goes into the AI. So instead of saying, here's stuff that makes you click more or like more or engage more, we've measured what makes you feel happier. And that goes in as input. We've plugged that into existing algorithms and shown that we can develop individual personalized models of what makes you happy and highlight that kind of content to you. I don't think this has to be just restricted to happiness. I think you could do this same kind of technique with things like making people better informed, for improving the social good, for highlighting kind of justice sort of things. And it's not even that we want all content to be like that, but I think playing with this idea of what do we want to optimize for what's going to make the world better and make people's lives better, and then leveraging that existing AI with new data and what's going to be new modeling and interesting sort of stuff on what we call preference elicitation, figuring out what you like. It's a really promising area. We've only done probably 3 studies in this space, and it's something that I'm hoping to dedicate a big portion of my work in the coming years to, because I think it's a way that we're going to be able to leverage social media and make it start fixing some of the things that it's kind of helped break over the last few years. I'll leave it at that, Mike.
Wonderful. Well, we'll get back and talk a bit more about making the net happier. Our next speaker is J.R. Rao. He comes to us from IBM Research, where he's an IBM fellow. Having worked at IBM, I know that means he is one of the true demigods of technology at IBM. But he also is the CTO of security research, and he'll be talking a lot about what IBM is doing to make the internet more robust and better for commercial applications. So over to you, JR.
Thanks very much, Mike, for your very kind introduction and kind words. So as Mike mentioned, my background is in security. I've been working in security for the past almost 25 years, really grown up with security in the internet era. And one thing that I can attest to is that, in our industry, we see that every time there is a platform shift, as we go from mainframes to PCs to web to the era of cloud, mobile, social, and now to AI, it is really the bad actors who are the first to take advantage of the technologies or the democratization of technologies. And it is the defenders who are playing catch up. And that is very much the case even now as we move into the era of AI. It is the bad actors who are the first to adopt some of these tools. So much so that I feel confident in saying that the future that we are going to envision, that we are barreling towards, is one in which it's going to be AI versus AI, right? And that we need to be able to prepare for that future. Now, let me try to unpack to you very quickly what this means, right? When we talk about the crossover between AI and security, there's an aspect of using security to do better AI. And then the second aspect is how to secure AI services. Almost all enterprises are experimenting with the use of AI. And how do we secure AI services that are being deployed by them? So let me take the first one and say a few words on this. So what we are seeing in the space of using AI for security is that the bad actors have already started using AI tools to craft attacks that are much more evasive, much more pervasive, and much more adaptive. I think one of the examples here is a tool that was called DeepHack, and which basically provided the capability not just to launch SQL injection attacks, but to learn the language, the SQL language, as on the fly. So this is truly a terrifying aspect of how AI can make attacks much more adaptive. And we at IBM Research have been trying to explore where this capability can go. And about a year ago, we showed a piece of malware which had AI embedded in it called Deep Locker. This was shown at the Black Hat conference in 2018. And this is a very targeted piece of malware that can avoid most security controls that enterprises are deploying today. And so there's a question of how do you protect against that? And so, when you talk about using AI for defense, AI means different things. There's an aspect of using machine learning. There's an aspect of reasoning. There's an aspect of using natural language processing. And really the question becomes, how can we incorporate these capabilities, doing big data analytics to do better job at finding the proverbial needle in the haystack, using natural language techniques to be able to get threat intelligence to our security analysts in a very timely fashion, and then doing things like doing active techniques like, for example, cyber deception to be able to protect our enterprises. And the good news on this front is, you heard my colleague here, Bill Shirless, mention some of the DARPA programs like DARPA Transparent Computing and DARPA Chase, Cyber Hunting at Scale, where the industry is coming together and creating technologies, and many of these technologies result in things that we put in open source that everybody can benefit from. Just a quick word on the flip side of this equation, which is on securing AI services. I think Jen actually talked about this as to how AI services can be targeted to steal some of the models, some of the training data that underlies them. The good news here, really, in my opinion, is that I think the defenders are a little bit ahead of the attackers. And in particular, I should really call out DARPA's GUARD program, which is guarding against adversarial deception. And so, again, this is also resulting in not just a set of attacks and countermeasures which can protect such AI services, but these are all being delivered into the open source so that enterprises can take advantage of this in a timely fashion. So this whole space, I'd like to end with by saying this crossover between AI and security is extremely important, which is why I think governments across the world are invested in this, including our government in the United States. And this future of AI versus AI is one for which we need to prepare ourselves. Back to you, Mike.
Thank you. Thank you very much, JR. And I now have one more thing to be scared about. And you summarize it perfectly with the tweet, AI versus AI. And I posted a link to an article about Deep Locker for those people who want to hear more. Our next speaker is Miranda Bogan, and she has one of the fastest changing jobs in Washington. She is policy manager for artificial intelligence and machine learning at Facebook. And since the technology is changing so fast and the policy is changing so fast, she doesn't sleep. So Miranda?
Thank you. So I think the most important point that I'll talk about is how AI is really a core technology that's part of anything that we're doing at Facebook, even the things that maybe don't seem like they're relying on AI. So as Jen pointed out, a lot of what's happening is ranking of content so that people can see the content that most interests them. That's very complicated to try and understand what really will bring value to people. But there is so much information that people could see at any point from all of their friends, from all of the people they follow, from businesses they follow, that organizing that information is really important so that people aren't just deluged, right? But that's not the only way we use AI. We're also using it to tackle hate speech and misinformation, to do content moderation at scale, which obviously is quite complicated also, but really necessary when there are billions of people trying to share their opinions online, and some of them trying to share things that might be harmful, right? So using this technology to detect that type of content and make sure that there are eyes on it to make sure it's not spreading, right? But it's also enabling our broader mission to connect people. And one of the ways it does that is powering things like automatic machine translation between languages so that people can understand if friends are sharing something in a language they don't speak. And in general, helping enforce other community standards, preventing spam, fake accounts, coordinated inauthentic behavior, a lot of the stuff we're worried about leading up to 2020. And other exciting things are how it can really enable inclusion in different ways by providing automatic alternative text for images using computer vision. So really letting people who don't have the ability to enjoy kind of all of the content that's being shared online to get a sense of what their friends are sharing. We also have fundamental research going on at Facebook, not just kind of applied research, but some of the work we've done that's very timely recently is in response to the COVID pandemic, using data that's being shared about case counts. It's being shared online. That data is accessible to help inform academic partners and policymakers on where those cases might spike, using AI to do better forecasting. And also, going back to using the natural language processing to help do those translations, to translate really critical information about COVID to people who might not otherwise have that information. It's evolving so quickly. manual translation, wouldn't necessarily scale at the speed it would need to reach the people who need that information the most. Obviously, AI is not a silver bullet in addressing the pandemic, but it can play a part in amplifying some of the other interventions that we're trying to make on the platform, and that governments and policymakers are trying to make to respond to this global issue. We're also investing in helping the broader field and tackle some of those harder challenges, like we talked about deep fakes. That is something that is quite worrying, but there really haven't been many examples of deep fakes in the wild. So it's difficult to train models to detect them. So we actually launched, in collaboration with a number of partners, a deep fake detection challenge. And we commissioned a data set using actors who we had their permission to manipulate their video to actually create examples of what deep fakes could look like, so that teams could compete and train better models, so that when deep fakes do arise in the wild, we're better able to spot them and make sure people don't believe some of the things that they're being seen. And those are some of the things that we're doing with AI. There's a whole bunch more, but obviously, in addition to the benefits AI is bringing, it does bring risks and challenges, and we're working on those too. We have a responsible AI team thinking about all sorts of things like fairness, transparency, robustness, and I think on the question of what's the future going to bring. I think those are where we all need to focus, is making sure that AI is trustworthy, that it's not leading to unanticipated harms, and that we're thinking early as we're developing this technology about how to make sure it's doing the things we expect it to do, and that people have visibility and control around that. And part of that is understanding, as the other panels were talking about, what should we really be optimizing for, and other parts are just both for the developers to understand what different AI tools are doing through explainable techniques, but also to explain to people how AI is being used and how they can express their preferences, so that it actually serves them better.
Thank you, Miranda. And I know the most interesting question I could ask is the one you can't answer, which is, what are the cool things that Facebook will have in 2023? But we're going to have you back at IGF 2023, and then you can describe what's happened.
I probably don't even know, because they're still building it, right? It changes so quickly, as you said.
Exactly. Well, our next speaker is George Montañez. He is an assistant professor of computer science at Harvey Mudd College, and he kind of lives in two worlds, both the techie world and the social world, trying to understand the implications of this technology. So, George?
Yeah, so the way that I see it in terms of what AI and machine learning are going to do for the internet, there's kind of two broad things that I think are going to be life-changing for our society. The first is that AI is going to transform radically what we think the internet is and how we interact with it. So I was of an early generation that grew up with the internet being a new thing, right? And for us, the internet was something you went to. You went to a computer to get on the internet. Now I'm a little bit older, and the internet is not something you go to. The internet is something that you have with you, right? You always have the internet with you. In the future, now we're starting to see things like Siri was mentioned, or Alexa, so these different technologies where, because of natural language processing, it's possible for me to not have to type something at the internet and to extract knowledge from the internet just by having a conversation with it, right? Alexa's not really good for a lot of questions. My kids always ask questions for which her answer is, I don't know that one, right? That's a common one. But in the future, you can imagine as these agents get better, this could shift the way we perceive of what the internet is. It's something that we have living conversations with, essentially. The second thing is transforming the internet from a pile of bits into knowledge, right? And so it's kind of this Wild West right now that we have with all this information. Having a notion of machines that can transform that into semantic information. Bill mentioned earlier the symbolic AI. So trying to take some of these raw facts and this data and transforming it into usable knowledge. I think that's going to be pretty transformative. We already have projects such as at Carnegie Mellon, we have the Never-Ending Language Learner that is reading the web to try to construct an ontology of knowledge from the raw text of the internet. I think that's really cool. And I think that once we have that, that's going to enable applications that we can't even imagine right now, because we're going to have access to automated knowledge, essentially, right? But there's problems with that. When you read the web, you might end up reading Reddit or 4chan or 8chan. And so we have a lot of these systems that are trained on uncurated data that end up incorporating the biases in that data. And so my research group in particular are looking at how can we leverage the formalisms and the tools of machine learning and AI to try to represent biases explicitly and try to uncover them early, right? So we have these notions of being able to measure bias the same way that you would measure other things that you try to optimize against, and using that in ways to uncover things that might not be visible just looking at the system. So I'll leave it there.
Great. Let me just ask for a 1-minute answer to one of the questions that Andrew Campling posted, which is,
okay,
with regard to bias, can we hope that AI will fix itself?
No.
So AI versus AI in the cybersecurity field, but this idea that maybe we'll be able to get the net smart enough to recognize its own bias.
So we will have to build that in. So one of the key takeaways from the research I've been doing is that automated systems are very much just a reflection of the assumptions and biases we put into them. And so in that sense, if we build the systems to automate or to optimize towards trying to uncover things like this, then yes, we will have systems that do that themselves. But if we just leave the systems and hope for the best, that's a really big recipe for disaster. We're just going to end up with things that are going to reflect biases that we don't even know are there. And that could really embarrass companies. So we have the example of the Twitter bot from Microsoft, or Tay, right? That in 24 hours, it became pretty bad. So we don't want to repeat that. Yeah.
Great. Well, thanks. Our last speaker is Brenda Leong. She is the Senior Counsel and Director of Artificial Intelligence and Ethics at the Future of Privacy Forum. She really does cover a lot of territory, and so I intentionally added her at the end of the lineup because she is our ultimate wrap up or cleanup hitter. She's going to cover all the topics that haven't been covered and open up some more questions for the discussion. She's also done some incredible work, handbooks on how to think about AI, and particularly AI and privacy. So over to you, Brenda.
And no pressure at all with that build-up.
Great backdrop, by the way.
Oh, thank you. I just got a new webcam with a much broader view than I'm used to. And so rather than expose you to my whole kitchen here, I thought I would give you a lovely view of the Grand Canyon instead. So anyway, thank you very much for the opportunity to talk today. Lots of really interesting presentations so far that I really enjoyed, and appreciate the chance to participate and contribute, hopefully. So as cleanup, I'm going to talk about something that I'm sure is everyone's favorite subject because it's so technical and so measurable, and that's ethics. Michael and I talked about this, and I think I scared him a little, but I promised I wouldn't get into anything about like Kant or utilitarianism or anything like that, but we'll try to keep it much more practical. So since I'm not a philosopher by trade anyway, that's not too hard. So one of the points that was just made is that you don't go to the internet anymore. The internet is sort of connected to everything. We're there. It's embedded in the devices that we carry with us and in our cars as we travel, and of course everywhere else. And we're looking into the future now, where we're going to be having AR and VR and computer brain interfaces. And what should we be doing with all of those? How should we be considering those? How should we be thinking about the cans and the shoulds and the want tos of how those things are going to impact us as people, as humans, as societies? We all know, that Asimov had his 3 robotic laws, but what happens when there's really no separate robots? Like, we're the robots, or the robots are us, or we're all part of a system that's all connected together that doesn't really have those lines between actors and how people interface with each other. How should we be thinking about ethics and all of that? Who should be thinking about ethics as those systems are growing up and being designed? And whose ethics should be used? I absolutely am not going to answer all 3 of those questions definitively in a minute and a half, so don't get your hopes too high. But that these are hard questions shouldn't stop us. let's do a quick thought experiment back to the beginning of the 20th century when electricity was fundamentally changing our daily routines. The development of cars was fundamentally changing our mobility, and general industrialization was changing all of our social norms in pretty much every imaginable way. The role of children, educational institutions, the role of women, the relationship of workers and management. Any of that sound familiar or timely in any way? If you could go back and change something then, pass a law or establish a policy or create an industry standard, what would it be? And more importantly than what would it be is the question of why did you pick what you picked? That's the question that's based on our values and your ethics. And that's the questions that we can still ask now. What do we want our businesses and our families and our social institutions to look like in 20 years or 50 years? People talk about AI and things like facial recognition and the scary possible outcomes, and they hold up China as an extreme example. And they say, if we're not careful, we're going to end up as bad as China. Well, we weren't trending towards being like China before facial recognition technology was in place. So why are we scared that facial recognition technology in and of itself is suddenly going to impel us to be more like China? If we end up with ubiquitous public surveillance, it isn't going to be because of the technology that it came into existence as facial recognition, whether it's accurate or inaccurate. It's going to be because we compromised our national values around personal liberty and autonomy. It's going to be because we didn't protect the underlying rights and hold our leaders accountable. So yes, maybe we need or want a law about facial recognition technology, or maybe we want to explicitly limit its use by government actors, or maybe we want a general privacy law to protect our ability to be anonymous or obscure in public. We can have that law and we can protect that value. And then it isn't about the technology, it's about the ethical choice that we made to not allow public surveillance by the government or identification and tracking of protesters. And we can protect the ethics with more than just laws. We can do it with design choices and with programming decisions, and by doing all the work that people are focusing on right now about how to identify and manage bias in systems, in automated systems. So the answer is that people at all points in this process have a piece of the responsibility to think about ethics. They have their own personal ethics of integrity as an individual. They have the ethics of their profession regarding the responsibility to highlight issues or protect against harms as they carry out their role. And they have the ethics of their business or their organization more broadly to take a view of where things land in the real social and political landscape that we're operating in. The questions that the people in that spectrum should be asking are things like, can we keep misogyny and racism out of the AR and VR landscape? Can we develop projects and services that are easily used to support individual autonomy and personal freedom, but that don't enable tremendous group harms at scale, like digital identity systems or biometric identifiers? How can we use those things in practical and beneficial ways without harming oppressed minorities? In the early 20th century, we overshot what could be done versus what should be done, and we had to dial some things back. Child labor, safe working conditions, minimum safety standards for cars and food and the physical environment. It's our opportunity now to take that same focus and look at AI and machine learning based systems that are exploding all around us and see where we need to put up those boundaries, whether it's by regulation, by technological restraints, or by some combination thereof. But none of that will happen if we don't ask those hard questions and keep our eye on those underlying values that should be our drivers, and not getting too caught up in the technology and the excitement of what it allows us to do.
Well, thank you very much. This panel's worked even better than I had hoped it would, and we covered so many different pieces. And Brenda, you really did fill in the gaps. I have a couple quick questions based on things that people have been posting in the Q&A. And this question is primarily for Miranda and JR. And it really has to do with how good is this technology at this point for protecting our network and for protecting us from the threat of botnets that try to flood a website, and protecting us from bogus postings, emails, and the like. So I guess the question for both of you is to give us some numbers here. I mean, if we look at just the area of botnets that flood the internet, like the Mirai botnet, how much of the blocking that's being done today, the filtering that keeps the internet from getting too congested, has anything to do with machine learning as opposed to other techniques? And then going a little deeper into this other harder problem of how do you actually deal with content that's being generated by botnets and other other things. I recently saw a number that more than 1/3 of all the tweets that have a URL attached are not from humans. They're actually being generated by bots and by algorithms. So again, is machine learning? It's not. We don't have a plateau. We all heard Bill's comment, but we're on the learning curve. How far up the learning curve are we? How much of an impact does this already have in making the internet, websites, and social media platforms work better?
Miranda, you want to go first?
Sure, and I can start with maybe the second part of that question. I don't have any direct numbers on botnets or specifics about coordinated inauthentic behavior of that particular kind, but what I can say is, we are getting very good at detecting certain types of policy violating behavior proactively. We share that sort of information in our transparency reports, and there was a number of announcements earlier this year about our ability to kind of detect a number of different types of content early on. I think there's always going to be people who are trying to figure out a way to get around that ability. It's always going to be that cat and mouse, especially when you're talking about content. The words people use to refer to different things adapt very quickly. Situations adapt very quickly. Misinformation about COVID wasn't something that anyone had the ability to detect before COVID became a global phenomenon, right? And so that required really rapid response to learn quickly, both the people building the technology to learn quickly what we were trying to look for, and for the technology to learn based on examples to detect that sort of new behavior of people trying to spread misinformation about that. So I think the techniques are very good, but there's so much nuance in the world. If we're not talking just about spam or actual bots, we're talking about people who are there's perhaps partly automated accounts, but partly real, or actual real people who are trying to maneuver their way around community standards and rules on the internet. There's always going to be new things we have to learn to adapt to that sort of behavior, but also just to understand the nuance. People are really good at learning how to use emojis or alternative terminology as they learn what's being automatically detected, kind of maneuvering around that. So a lot of work, as I put in the chat, from our research team on adversarial techniques to try to preempt that sort of behavior. But I don't think we've reached a plateau. I think there's more to be developed.
So JR, what about DDoS attacks and other forms of AI?
Absolutely. So there's a lot that can be said on this topic, because I think there's a lot of progress that has been made. But let me try to be very concrete and give you two exemplars with some numbers that might actually give a sense of how effective AI can be. As I mentioned, AI means different things to different people. There's an aspect of machine learning for AI. Mm-hmm. So one of the problems we face in the security space is, the whole concept of, spear phishing attacks, where, you go click on a link and you download a piece of malware that resides on your laptop, and that periodically beacons out to a command and control, a cell outside, to get instructions as to what to do within the enterprise once it's gotten a foothold at the enterprise. This is called beaconing, and beaconing detection is a hard problem because the attackers are incredibly sophisticated. They don't beacon out in any regular pattern because you can catch that using statistical detectors. So they've tried they beacon for a little bit, they back off and randomly, and then they go out when they're ready. And there's some very incredible cat and mouse games that can be played there. Now, if you look at a typical enterprise, the number of connections that get formed, we looked at for a month or so, it's about on the order of 50 million connections. Now, you're looking for the few connections that correspond to a piece of malware actually beaconing out among those 50 million connections that you're seeing within the space of a month. So we actually designed a big data beaconing analytics solution that was able to whittle down these 40 million connections in phases until you came down to 18 devices. And this was in when we ran this as a proof of concept in a large financial institution. We had we had 250 devices within the enterprise beaconing out to 18 different malicious locations. So going down from 40 million, which is approximately 10 to the 7 or 8, down by 5 orders of magnitude or 6 orders of magnitude very quickly using a sophisticated algorithm in machine learning. So that's an example, and that isn't one exemplar, just one, because there are many such exemplars of how automation and machine learning and AI can actually use this. The other aspect I want to give you, I promised you a second aspect, is something around natural language processing. Mm-hmm. So if you look at our analysts who are sitting in security operations centers today, they are looking at screens in which they're getting alerts from devices that are monitoring enterprise security. And there's a never-ending stream of alerts that's going by, and their task is to look at those alerts, a large proportion of which may be false positives, so you throw them out, but then they see things based on something that's suspicious. Mm-hmm. Now, if you look into the what's happening cognitively in the mind of the SOC analyst, he or she is actually trying to connect what they are seeing, like an IP address or a port number, with what they have learned outside. So they may have read a report from a threat intelligence feed that says this IP address is the address of a command and control server, and they're trying to correlate. Now, analysts spend an incredible amount of time trying to scour their favorite sources of information outside to understand what are the techniques, tactics, and procedures that attackers are using, what IPs are bad, what registry keys are being written, and they have to carry it in their head, and that's a huge amount of cognitive overload. And this, an analyst easily spends 2 to 3 hours a day on this. What NLP provides you, natural language processing, provides you is a capability to be a single-stop shop where you can consolidate information, external threat information. So if an analyst can hover over an IP address, let us say, and get all the contextual information associated with that IP address instantaneously. Mm-hmm. So you're going down, again, quantitatively from an army of analysts spending a few hours every day scouring threat intelligence to having a single-stop shop where you can get this information. That is reducing the cognitive overload, the overhead that a SOC analyst, all our SOC analysts carry in their head. That is the promise of artificial intelligence.
Great.
So those are 2 examples, Mike.
Yeah. I'm going to follow up both with the 2 of you and with Bill Shirless to ask another part of a question that Suvash asked on the chat. He had like 3 questions, one of which JR already answered in the chat. But do we know where these attacks are coming from? Where is the AI attack business really growing? Is it any particular countries? Is it organized crime? Is it nation states? I know it's hard to know where the threat is, but do we know who's behind some of this? Who are the most sophisticated users of AI for bad on the internet? And others can chime in here if you have any data.
I'll just make a quick comment. Really, first I want to just echo what JR said about the challenges of making connections and taking really vast oceans of data and extracting from those vast oceans a few critical bits of information that may point you in the direction that you need to be pointed in order to, for example, put an end to an adversarial attack. And DARPA has a number of programs that focus on this. We're all internet users. We're all aware of the extent to which data is being generated from just the ordinary course of activity. And if you're running a corporate data center information processing facility, you're generating an extraordinary amount of log data, or you should be generating an extraordinary amount of log data. And that's on that basis, typically we do, if an attack occurs, that gives you a means to do forensic analysis to try to understand what happened, but it's a lot better if you can do some real-time analysis and detect things as they're happening. Of course, the problem with the real-time analysis is too many false positives. And so that analyst's sitting there with the alert popping up, well, JR mentioned these alerts. There's something they call alert fatigue, which is, you get all these pop-ups, warning, this website is dangerous. And if you get too many of those, you start to just dismiss them and proceed on. And so one of the challenges that we face is how to reduce the extent of false positives without compromising on false negatives, because you really don't want false negatives. And so these, we have data-intensive programs. Enhanced attribution is one of them, trying to figure out actually where attacks are coming from. Another one is called CHASE, which stands for, I'm going to try to remember what this is called, cyber hunting at scale. The scale refers to the more data than you can store. Think about everybody in the Department of Defense being online, trying to figure out who's doing what in this space, what adversaries are trying to get in, and what they might be doing. So this challenge of digesting the large amount of data and making it usable by human analysts is a combined challenge of just data analysis, but also building AI tools that can adapt to the changing tactics and techniques of the adversaries.
Okay, so I usually ask questions that involve numbers because I'm a physicist, but let me ask this same question in a Hollywood style. If I'm writing a James Bond movie about some evil villain who's using AI to attack the internet, what kind of person is it and where do they live? So Miranda, JR, can you help me write my script?
Miranda, you want to go first?
You go first this time.
Okay, all right. So, I think, let me tell you one thing. So are the bad guys actually using AI to craft attacks? Which tools are they using? You will not have a definitive answer to that. What you're going to see is you're going to see an increase in the scale, in the scope, and the frequency of the attacks. They become much more targeted, much more successful. And it'll be attributable to attackers using AI. And I use AI in the sense of augmented intelligence more than purely artificial intelligence to be able to do this. Now, what are the addresses of these people, right? Let me take that question head on. You may see there's a report on something called Artificial Intelligence and National Security that was put out by Greg Allen and Daniel Chen at the Belfer Center at the Kennedy School of Government at Harvard a couple of years ago. They point to the huge investments that nations and nation-level actors are making in AI. China, Russia, India, many of our traditional competitors and adversaries are investing in these spaces. So nation-state actors tend to be have large resources at their disposal. It doesn't mean that they are the only ones working in this space from the perspective of bolstering national security. We have all the traditional actors, be it organized crime, be it people who are out, the traditional armies of spammers who want to do much more targeted attack by scraping through your Twitter feeds to see what your profiles, your interests are, and then targeting tweets that you are bound to click upon and get spearfished into. So you have all the traditional actors that play in this space. What we see happening in this space is the traditional commoditization that happens even in the attacker community. The attacks start with very well-resourced adversaries, and slowly, sometimes it's nation states, sometimes it's organized crime, or it's competitors, industrial espionage. But then very quickly, as they become much more automated, much more scripted, we see these become available on the dark web, and these get used by different actors.
Okay, I'm going to turn to Miranda, and you probably at Facebook know about some of these people by name. Maybe even working with the FBI to find them. So give me the name or the location of some nasty person who is, I don't know, trying to corner the market in cryptocurrency or whatever. What's the scenario here?
Well, I think the answer for Facebook is that there are just so many different types of things people are trying to do, right? When you're serving the size of community we're serving, we're just seeing creative people everywhere using platforms in ways that we didn't anticipate, right? So I
So
think
you're just building on JR's point, which is it's everybody, and I get to make 5 different movies with 5 different villains. Is that okay? Let me turn it to the other panelists and get it a little bit more into the questions that people are asking about regulation and ethics, and in particular, if anybody, if Brenda or George or Jen could talk a little bit about what they would do if they were, queen or king for the day, if they were king of the internet and could put in place one regulation, one thing that would make AI better for all of us, what would it be? Jen, do you want to go first?
Sure. I got so many things I'm going to do in that one day if I'm in charge of this. Yeah, no, if I get to pick one, look, I mean, I think there's 2 sorts of problems that we're facing. I think the privacy is really one of the big ones. And then I think sort of to some of the other points that were made earlier, this sort of harassment, misinformation, sort of like what I would call malicious content is another problem. So I'd kind of have to pick between those 2. Frankly, I think the potential for real regulation is better on the privacy side. So I'm going to leave that one for now, just because we can see some real solutions. Solving that kind of bad information, malicious content is a harder problem, I think. So if I get to solve that problem, I don't know if one rule could do it, but I think part of it that pulls together a lot of what everyone was saying is that, absolutely, if we have AI working on that, George really spoke to this, it's just reflecting our biases. And so I don't see AI just as a straight solution to that problem, because our biases are so deep, and you can't just be like, oh, AI, in this space, don't be biased against women, even though we traditionally have been. So if I can take a minute to do an example on this, Amazon, one of the examples I give, and Mike, you've probably heard me give this, is what you don't want to use AI for is hiring. Yes. Let's feed some resumes in for people who have been good in this job, and then we'll train AI to see what a good one looks like, and that's who they're going to hire. Amazon did not listen to me. They spent 3 years and who knows how much money building one of these algorithms to hire software engineers. It was so sexist that it learned what the women's colleges were without being told. It was like, we will not hire anyone from one of these colleges because we don't hire women as software engineers. And even as it's like, so we'll tell it not to look at the word woman. We'll tell it not to look at this and this. The AI doesn't know what any of this means, right? It just knows that there's statistical patterns, and the hiring patterns for software engineers is don't hire women. And so it finds other statistical things in the data that don't even make sense to humans that signal, oh, this is a woman. This is one of those things we don't want to hire, right? It doesn't understand what a woman is, doesn't know what hiring is. It just knows that the patterns are there. And it's so deep what this bias is that the AI will learn no matter what we do to try to correct it after the fact. So, how do we fix that? If I'm in charge and I want to try to fix that problem so the AI can be better, if you let me, I'll fix those societal bias problems. But assuming that's not an option, I think one of the things, and this sort of speaks to Brenda's comments too, is that we do have these rules about what's allowed and what isn't. And if we had really good data, right, if everybody who broke the rules got punished and correctly flagged for it, that would be really good input to the AI. The problem is these rules are absolutely not fairly enforced on any platform. And Twitter is a great example to look at with this, where they've, finally been kind of in the last month going like, okay, Donald Trump's tweets violate all of these terms that we wouldn't let anybody else do, but we're leaving them up because of this reason. But for a long time, and certainly now as well, there's lots of stuff that's being allowed to go up, even though it explicitly violates those rules. And of course, this is a hard problem to solve, right? Moderating content. But I think if we could come up with, here are the rules, really consistently enforce them, build up that data, that then becomes a basis for models that I think would be more effective at moderating all kinds of this malicious content. So it requires that human solution, but that really is like a human decision-making policy solution. And I think it would go a long way towards giving us what we need to do better on that problem.
Great. George, do you have an answer to this?
Yeah,
You were
So
king
I
of
would
the internet. Well, what one thing would you do? Not what one problem would you address, but what
Right.
one thing would
What
you do?
one thing would I do? So I want to follow up with what Jen said. I agree largely with what she said. One thing, before I get to the one thing, Larry Wasserman at CMU, when I asked him once, why does machine learning work? He said, because the future is like the past. And in these systems, the problem is that sometimes the future will be like the past unless we change how we're learning from the past. And so if I had one thing to do, it wouldn't be a technological solution. It would be a sociological solution, which would be, where do we place the responsibility when these things go wrong? If we make the people who create these systems responsible when these systems have bad outcomes, I think that's going to make decisions like the ones made at Amazon about building such a system much more weighty. And people are going to think much harder about, in what possible ways can these systems go wrong, as something to optimize, right? This isn't just something that we figure out once the system is out in the public and we get bad press. This is something that's built in from the beginning. So that would be my one decision I would make, is shifting where the blame is placed, if you put it that way.
Okay, but let me just ask the hard question. How do you know if it's the software designer or the data provider or the person who actually took a tool that wasn't meant to be used the way they used it, but they used it? So I mean, there's at least 3 different agents here who might be blamable.
Right. And so I think an analogy with vehicles, right? So if you have a vehicle, a lot of things can go wrong and end up bad. And this is a tool that is used by people that could be used in good ways or bad ways, or it could be because of manufacturing defects. You could have cars that explode, et cetera. Something similar is going to happen with our AI systems. We will have to be smart about how we trace these things, but definitely we need to make that an option, that there's accountability with the manufacturer of the AI, right? Okay. That if they didn't build in sufficient safeguards, that's going to cause liability.
Right. So Brenda, we heard a lot from Jen about privacy. I know you've thought deeply about this question. If you're queen of the internet, what's the one thing you do to solve some aspect of, to make the internet better and to make use of AI better on the internet?
Well, I think along with the point that both Jen and George made, is that there's not necessarily a technological solution that I can impose on the internet that will fix what are essentially human problems. And so, you know, Jen's example of the Amazon thing, maybe we can't or shouldn't use AI systems for hiring, but maybe we should use them to analyze the existing hiring data and patterns to identify the fact that Amazon was already, and I'm assuming, I'm not pointing fingers at Amazon here, but that, you know, there was already discontinuity in their hiring patterns, and that's why the new AI system learned it. So maybe we need to just use it as a tool to identify where we're already failing, and that would be one of the ways to accommodate that, or to George's point about accountability for it. Love to have that conversation about guns, you know, about who's going to be accountable for something that gets misused in a way it wasn't intended. So if we're going to put that in as our value over how we're going to hold people accountable, or businesses accountable, or various people in the supply chain accountable, then that might be something we have in more than just an AI context. So consistent with my comments earlier, I would actually take it out of the technological point and put it in the, what is the thing that we want to protect? What is the human dignity or value that we're trying to uphold? And so whether my one thing would be establishing a fundamental privacy law for the US, or establishing some fundamental privacy regime under a UN auspice that would sort of encompass, you know, globally some sort of level of agreement of standards and accountability, would probably be the tack that I would take.
Okay. Miranda, you're on the receiving end of a lot of regulation. If you were queen of the internet, is there something that would help you as Facebook apply these technologies in smarter ways and better, effective ways?
Yeah, well, I mean, I think Jen and George and Brenda's points are all fantastic, and they are things we're thinking about every day, about how to actually be aware of the potential harms of technology and build that in. And I think the challenge there, and what I would hope for is that actually translating the kind of high level goals of avoiding these clearly bad things into what does that look like at the technology level, and what processes do you need? It's really challenging. There's sometimes to detect those harms, you might need more data, and that might go against sort of privacy values. And so more collaboration between the stakeholders here, between policymakers and the folks building the technology, and also people to figure out how to actually implement some of those goals, and some allowing for some experimentation, because I think as we all identified, the technology here is evolving so rapidly, and it seems like kind of existing controls might apply. There are harms that are very clear, but figuring out the right way to shape what that technology does is something that we want to work on together. So we've started working with the government of Singapore to do some regulatory sandboxing, some experimentation, and I think more collaboration in that way to figure out what does this actually look like on the ground with the folks building this technology is great, because I would love for us to do everything that we're all saying here, and avoid all the harms possible. But just figuring out what that means in practice is definitely a challenge.
Mm-hmm. I wasn't going to ask Bill Shirless what the government could do or should do, since he is in the government, but
we're here to help, Mike.
Please do. Please tell us what you would do if you were, well, you're not king of the internet, although you used to be. When I first met you, you were one of the 10 or 15 princes of the internet who were actually doing all the technology development that made it all happen back in the 90s. The secret society of geeks. Anyway, what problems do you think we're not spending enough time on here?
So I just want to say there's a sense, that again, maybe it's the plateau effect that sort of AI is taking over the world. We used to say 5 years before that, software is taking over the world. Software is still taking over the world, but the idea that AI is taking over the world, I think, is fraught, because it gives us a sense that AI is somehow going to displace a lot of the concerns that we must never put aside, relating, for example, to accountability, allocation of responsibility and liability, the nature of risks we're taking. And I just want to make one point about bias, because the word has come up many times today already, and this is an example, I think, where this notion that sort of somehow AI expertise displaces all other kinds of expertise. If you take experiment design 101 or empirical studies 101, you learn about how to make good choices for the independent and dependent variables in your data collection activity. What's happening a lot, and I think in a lot of these cases of bias, is that the data is data that happens to be on hand. It was collected in a manner that was not informed by a particular experiment design. The choice of variables is accidental, and we want to proceed with that data because it's at hand, and we want to set our TensorFlow library or whatever loose on that, and so we get bias because we picked the wrong independent variables. And so I think it's really important that we think carefully about the general principles of empirical science, and in making the correct choices of variables as we try to associate inputs and outputs through the use of AI. AI is one tool in the toolkit of doing these statistical analyses, and it's important to keep that in mind, because the bias is not something to do with the AI. The bias is something to do with the choices that we humans are making regarding what sorts of data we're presenting to those AI algorithms.
Yeah. Okay, we're into the lightning round, the last 5 minutes. What I'd like to do is have everyone give us their tweet. Bill has given us his tweet already, which is, there is no AI plateau. And I think that's a very useful one. I'm going to go in reverse order from how we started. So Brenda will be first. But the goal is to really, literally give us something intensely tweetable that will just explode all over the Twitter sphere. So short, powerful, pithy visual. No pressure. I would also welcome the panelists to go on the Q&A, and if there's a question that hasn't been answered, provide some inputs. JR has done that on the chat as well. This is a multi-platform experience, so please do that. And I'd also tell everyone again that there are now 4 questions on Twitter that I've posted asking about AI and what they've learned from this panel. Please answer that. And I'm Mike Nelson on Twitter, or you can just go to the @ IGF-USA, and that should pop up right there. So anyway, Brenda, what's the tweet that we want everyone to remember?
I usually have to edit my tweets for a long time to get them down.
I'm sorry I didn't warn the panelists ahead of time.
This might still be a little long, but if we end up like China, it will be because we compromised our values, not because facial recognition drove us there.
That's a very powerful tweet, and it answers directly one of the questions that was in the Q&A from Rick Lang. Okay, so George, your tweet.
I don't know how powerful it is, but I would say that data is biased, but so are systems, because assumptions bias systems in various ways, and all of our systems are built on assumptions.
Excellent, excellent thing to remember, the cautionary note. Okay, that means, Miranda, your chance. I mean, I'm sorry to keep talking about Twitter, but you know, what's your short Facebook post?
I'm not offended. I would say, you know, AI is a tool that offers great benefits and also some risks, and we need to think carefully about how to balance those and continue moving forward, but being responsible in how we're building this technology.
Thank you. I think responsible is a great word. I know I'd given Brenda a hard time about ethics, and I think ethics are critically important, but responsibility may be an even better word. I find, at least when I worked in the IT industry, I walked into a room and started talking to engineers about ethics, they just shut down because they didn't take philosophy or ethics in college, and they didn't know where to go with the conversation. But responsibility, they could deal with that. JR, what's your tweet?
Yeah. So Michael, first of all, let me just say one thing before I give you the call out in the tweet. Really like to call a shout out to DARPA, and I say this not to flatter my colleague Bill here or DARPA, but I say it because they truly are creating technologies and running programs that keep us ahead of the threat. And thank you for doing that. We love to work with DARPA. Hope to continue to work with them. And it's really an asset for us. Regarding the tweet, I think I gave you a tweet around AI versus AI, but I'll give you another one. Mm-hmm. I think the pandemic of cyber insecurity has been with us for over a decade. Mm-hmm. And we do have tools, especially with AI, that can help. It's up to the defenders to embrace and deploy them.
Mm-hmm. Excellent. I have to say, IBM has gotten much better at tweets and bumper stickers. I worked at IBM about 20 years ago, and the joke was, if IBM had invented sushi, it would have been called cold, slimy, raw fish. And what you just said was much more powerful. So I'm glad we've got a way to convey that point. So Jen, one thing I did not mention is that Jen is a radio star. In addition to being a digital maven, she's substituted for Kojo Namdi here in Washington, D.C. on NPR. So she knows concise communication.
Okay. AI puts a veneer of mathematical objectivity on top of human decision making. And I think the solution to our problems is not more AI, but more careful thought into what those decisions are that we're asking it to make for us.
Thank you. That's profound. It's something other people have, a couple of people have stressed that theme, that AI is only as good as the humans that develop it and use it. I want to thank everyone for an amazing panel. We did cover 3 hours of material in 75 minutes. We did not get to answer all the questions, and I would invite our panelists to stay on, and we can perhaps have a little informal discussion after they stop the recording, and those who are on the Zoom call at least can continue for a few more minutes. Dustin, is that allowed? Can we have a little more time?
So yeah, absolutely. If you'd like, the other alternative is that, so we do have a 30-minute break here. So our next session will be starting in 1:15. It would be better to have this room open for the next panel to get staged, but we can use the green room, and I can
Well, but the people who have tuned in, can they go to the green room?
Yeah,
we use this for 15 minutes and just wait until other people gather.
Okay, if you'd like. I thought we had discussed the green room that everybody.
Well, we had, but I just realized we've got 141 people who might want to ask questions in the chat and might want to interact with the panelists. I wanted to do the equivalent of passing out business cards, right? Because that's what happens after every panel I've been to, is people in the audience want to come up and introduce themselves and ask a question. So if we can turn off the recording and then we can have people type questions in the chat, we can finish the official part of this and just hang out for 15 minutes with the panelists.